Hi, good day my dear grade 11 students. So how are you today? I'm hoping that all of you are doing fine and safe at home. So for now, we're going to discuss about logarithmic functions. In our previous lessons, we have studied inverse and exponential functions. In this lesson, we shall learn the inverse of exponential function called logarithmic function. We shall examine the properties of logarithmic function by analyzing its graph. And of course, in our previous lesson, we have pointed out that the exponential function is one-to-one. Since every one-to-one function has an inverse, it follows that exponential function has an inverse. Recall that the inverse function is obtained by interchanging the roles of x and y. Thus, the inverse of the exponential function y is equals into b to the power of x is x is equals into b to the power of y. However, we do not have a way of expressing y explicitly in terms of x in the equation x is equals into b to the power of y. To do this, we introduce another terminology to be able to express y in terms of x in the equation x is equals into b to the power of y. The equation x is equals into b to the power of y tells us that y is the exponent to which b must be raised to produce x, wherein y is the exponent on b that produces x. We use the term logarithm to replace the term exponent. A logarithm then is an exponent. We can now say that in the equation x is equals into b to the power of y is the logarithm to which b must be raised to produce x. In other words, y is the logarithm on b that produces x. We write y is equals to the logarithm of x to the base b. So what do we mean by logarithmic function? For all positive real numbers x and b is not equals into 1. The inverse of the exponential function y is equals into b to the power of x is the logarithmic function, wherein y is equals into the logarithm of x to the base b, or f of x is equals into the logarithm of x to the base b. So the definition of the logarithmic function emphasizes that b is greater than 0 and x is greater than 0. Thus, logarithm is defined only for positive real numbers. Okay class, for now, let us study on how you are going to write an exponential function into a logarithmic form. Okay class, for example, we are going to write this exponential equation into logarithmic form. So for example, our given is 2 to the power of 4 is equals into 16. If we are going to rewrite this into a logarithmic form, so 2 to the power of 4 is equals into 16 is equivalent into the logarithm of 16 to the base 2 is equals into 4. Another example, for example, you have 3 cubed is equals into 27. So if we're going to write this in logarithmic form, so this is equivalent into logarithm of 27 to the base 3 is equals into 3. Another example, 1/2 to the power of 3, or 1 over 2 quantity 3 is equals into 1 over 8. So this can be written as logarithm of 1 over 8 to the base 1 over 2 is equals into 3. Okay class, now we know how to write an exponential form or exponential equation into logarithmic form. For now, we're going to rewrite a logarithmic form into an exponential form. For example, your given is logarithm of a to the base 4 is equals into 16. If we're going to write that into an exponential equation or exponential form, that is equivalent into 4 to the power of 16 is equals into a. Okay, another example. For example, your given is logarithm of 8 to the base 2 is equals into 3. If we're going to write that in an exponential form, that is 2 to the power of 3 or 2 cubed is equals into 8. Another example, logarithm of 1 over 125 to the base 5 is equals into negative 3. So this can be written in an exponential form as 5 to the power of negative 3 is equals into 1 all over 125. Class. So now we know how to rewrite an exponential form in a logarithmic form and a logarithmic form into an exponential form. Let us now study or learn how to evaluate logarithm. Okay, class. For example, your given is we're going to evaluate logarithm of 243 to the base 3. Remember to follow the 2 steps. The first step is you let y is equals into the logarithm of 243 to the base 3. And then express equation in an exponential form. Of course, y is equals into the logarithm of 243 to the base 3. This is equivalent into 3 to the power of y is equals into 243. And then after that, we are going to solve the exponential equation. Remember that express the both sides of the equation using the same base. In using the property, if b to the power of x is equals into b to the power of y, then x is equals into y. So therefore, you have 3 to the power of y is equivalent into 3 to the power of 4. As you will notice, we have now same base. We're going to solve for our y or exponent. We have y is equals into 4. So thus, okay, have your final answer. Thus, logarithm, of course, we have logarithm of 243